Good afternoon, everyone. Today is Monday. We are in week 3 of online learning, and you guys are still continuing to do an excellent job. Keep it up. You're doing what you're supposed to do. I can see the multiplication division quizzes are looking good, as well as the last quiz that we just took was very good. So keep that up. One thing I want to mention is make sure you're taking breaks, because remember, these are recorded videos, so you can watch them at any time on our YouTube channel. So you don't have to watch it at a specific time, as Bruce and I just have the schedule for you if you need something fully detailed in your day to do. So you can watch it at any time during your day. You can even watch it the next day if you don't have time to watch it today. Okay, so remember, you don't have to overwhelm yourself with doing absolutely everything, because you're doing it online, so you have the extra time. Okay, now before we get into page 1 and 2 of 1 through 16 cumulative review, I'm going to play a flowcab video for you on place value.
Flowcab. You know, numbers change when you move them around. Listen, you could have a 1 in the hundreds place, and a 1 in the tens place, and a 1 in the ones place. That's 111. Yeah. You could have a 3 in the hundreds place, and a 2 in the tens place, and a 1 in the ones place. That's 321. Yeah. You could have a 5 in the hundreds place, and a 9 in the tens place, and a 3 in the ones place. That's 593. You could have a 6 in the hundreds place, and a 6 in the tens place, and an 8 in the ones place. That's 668. Yeah, if you're listening, you know the game. Not all numbers are the same. Values change in a place. Okay, we move a number, switch a number, drop a number, flip a number. If you're listening, you know the game. Not all numbers are the same. Values change in a place. Okay, we move a number, switch a number, drop a number, flip a number. You could have a 9 in the hundreds place, and a 4 in the tens place, and a 2 in the ones place. That's 942. You could have a 3 in the hundreds place, and a 0 in the tens place, and a 9 in the ones place. That's 309. Come on. You could have a 1 in the hundreds place, and a 5 in the tens place, and a 5 in the ones place. That's 155. Yeah. You could have an F to the L to the O, and a C and an A and a B, and a U and an L and an A, all Y vocabulary. Yeah, if you're listening, you know the game. Not all numbers are the same. Values change in a place. Okay, we move a number, switch a number, drop a number, flip a number. If you're listening, you know the game. Not all numbers are the same. Values change in a place. Okay, we move a number, switch a number, drop a number, flip a number. Yeah, if you're listening, you know the game. Not all numbers are the same. Values change in a place. Okay, we move a number, switch a number, drop a number, flip a number. If you're listening, you know the game. Not all numbers.
All right, I hope you guys enjoyed that video on place value. Now we're gonna get right into going over page 1 and 2 of your 1 through 16 cumulative review. Okay. Now in just a moment, well, actually throughout the entire video, I'm gonna be using my Elmo because I finally figured out how to do that. So if you need to pull up the questions on the side or have it next to you, make sure you have it next to you or up to the side, because I'm not sure if I'll be able to have it at the same time as showing my Elmo. So if you need to see the words as I'm going over it, maybe you need to pull that up or have it to the side, okay? All right, so beginning with our first question, it says, Lonnie's goal is to exercise for at least 3 hours every week. 4 days a week, he runs for 40 minutes. Will Lonnie make his goal? Choose the best answer. So when we go back into that yellow part, his goal is the 3 hours every week. We know that he runs 4 days a week. He runs 4 days a week, he runs for 40 minutes. So let's take a look, okay? I'm gonna flip my camera here. All right, so when we're working this out, the first thing that we need to know is how many minutes are in an hour. And the answer is 60 minutes. We know that 60 minutes are in 1 hour. So when I have 3 hours every week is his goal, and we know that 3 hours every week is his goal. So we know 60 plus 60 plus 60. We know that those are that represents 3 hours, because 60 minutes are in every 1 hour, okay? So 60 plus 60 equals 120. 120 plus 60, okay? That equals 180. So that's his goal, is 180 minutes, okay? Now, when we go back into our question, it says 4 days a week, he runs for 40 minutes. So 4 days a week, he runs for 40 minutes. That means we're going to multiply. Now we know how to multiply by multiples of 0 because all we need to do is cover that 0 and do 4 times 4, and that equals 16, and bring down that 0 that we see in our problem, and that is 1, 0. So 160 minutes is what he actually did, and 180 minutes was his goal. So it says, will Lonnie make his goal? Choose the best answer. Your answer would be C, no, because 3 hours is 180 minutes, and he only completed 160 because he does 4 days for 40 minutes, okay? Now, number 2 says, draw a picture and write a fraction to represent the whole, okay? So when you're thinking about the whole for this specific question, I won't need to write anything. I'll just go ahead and speak on it. So it says represent the whole. Draw a picture and write a fraction to represent the whole. We know that the whole would be 8 total parts because there are 2 out of the 8 that you can see on number 2. So there's 2 currently out of the 8 that you know. So you know that the whole would represent 8 over 8 once you finish the picture and go towards the very end. Okay, so if I were to draw a picture and write a fraction to represent the whole, I would continue with the triangles and the pattern that I see, and I know that there would be 8 because I'm seeing 2 out of the 8 for number 2 right now. Okay. Now, number 3 says, use properties of multiplication to show why 5 times 40 equals 10 times 20. Now, I'm going to flip my camera, so go ahead and pull up those questions if you need to see it as I'm going over it. Now, when you're showing your examples of how these would be equal to each other using the properties, all you need to do is just simply show the distributive, the commutative, associative, whichever one applies, whichever ones that you can do. So taking a look at my examples that you should have maybe had, maybe 1 or 2 of these. I had 5 times 40 equals 5 times parentheses 2 times 20, okay? And when I solve for these, they will equal each other, okay? 5 times 40 equals parentheses 5 times 2 times 20, okay? And then the simple version, 5 times 40 equals 10 times 20. Now, for those that are more focused on the simplified version, 5 times 40, cover that 0, 5 times 4, okay? 20, bring down my 0, that's 200, okay? 10 times 20, I cover my zeros. I have 2 times 1, that's 2, and then I bring down both zeros, and that equals 200, okay? All right, next question. It says, Brody drove 384 miles on Saturday. After 3 days, he had driven 861 miles. How many miles did Brody drive on Sunday and Monday? Show your work, including regrouping if necessary. All right, so this is going to require some subtraction here because it says how many miles did Brody drive on Sunday and Monday, and all we know is how many miles he drove on Saturday, which is 384 miles, and then we know how many he had driven total after the 3 days, which is 861. So we need to figure out the difference between 861 and 384 to figure out how many miles Brody drove on Sunday and Monday. Okay, so I'm going to show that subtraction on my paper. So you may want to pull up the questions if you need to. All right, now when we're working out these problems, this is a subtraction problem because we're trying to figure out the difference between 861 and 384. So simple subtraction, make sure you line it up. 861 minus 384, okay? Now this 1 is, of course, going to become an 11, and this 6, of course, is going to become a 15 because we cannot do 6 minus 8, we cannot do 1 minus 4, so we're going to continue on over. This 8 is going to become a 7. So now that we have done all that we needed to do as far as regrouping, 11 minus 4 equals, okay, 7. 15 minus 8 equals 7. And then we have 7 minus 3, which equals 4. So we have 477, but not just 477, 477 miles. So our answer is 477 miles. All right, our next question, number 5 says, 3 friends want to equally share 1 hour of time on a computer at the library. What fraction of an hour will each friend have to use the computer? So we have that each friend, we have 3 friends, equally share, and they want to share 1 hour of time. So out of the 3 friends, they want to share 1 hour of time, which means what fraction of an hour will each friend have to use the computer? We know that it would be D, 1/3. We have 3 friends, and they want to share equally, and they want to share 1 hour of time. Okay, all right. Number 6, it says find 483 plus 316, use place value to find the sum, show your work. Now we're gonna save some time and we're gonna go ahead and just solve this problem. We know that the keyword sum means to use addition as well as using that plus sign that's given to you, okay? So we're gonna solve this in addition. We're not gonna use the place value. If you use place value, well done. We're gonna save some time today. For those that did that place value, I went ahead and put it right here. So you have that 400 plus 300 equals 700, 80 plus 10 equals 90, 3 plus 6 equals 9. Okay, so that was probably the longest part. Now let's go ahead and try just a simple addition. So for those that did simple addition, I'll take that as well, absolutely. 3 plus 6 equals 9, 8 plus 1 equals 9, 4 plus 3 equals 7. So our answer is 799, okay? All right, our next question, we're on number 7, we're on page 2 now. Number 7 says, Mark stopped at 3/5 the distance from his home to his cousin's house. The 0 represents Mark's home and the 1 represents his cousin's house on the number line. Divide the number line into equal lengths and label the point where Mark stopped. So when we're taking a look at our number line, we have 0 and then we have all the way to 1. If Mark stopped at 3/5 the distance, we're gonna go ahead and draw that on the number line. So I'm gonna go ahead and flip my camera so you can see that. Right now, as I've told you before, when we're making number lines and we are labeling points such as fractions on there, we want to make sure we have equal number of parts, which means we want to at least have our number line looking somewhat even. It's not going to be perfect, but we have to figure out how to make it even. And just make sure you space it out pretty good, and you should be fine. Okay? Now, if it says Mark stopped at 3/5 the distance, that means that this is going in fifths. So our whole, we know, would be 5/5. So now all we need to do is figure out where 3/5 would be. So after 0, it would be 1/5. After 1/5 would be 2/5. After 2/5 would be 3/5. And here's our point right here. Make sure you label it, okay? And then after 3/5 would be 4/5. And we already solved for the whole, which would be 5/5, okay? All right, number 8 says, write an addition problem with 3-digit numbers that requires regrouping. Then write an addition problem with 2 3-digit numbers that does not require regrouping. So you should have done this, but I'm going to give you my examples, and then we'll quickly move to the next question, okay? All right, so here you'll notice I have 2 examples. Here is my regrouping problem, and here's my non-regrouping problem. So I'm just gonna put no, okay? So no regrouping here and regrouping here. Regrouping because here I'm going to need to carry up my numbers. I'm going to need to borrow. So had a little technical problem here. Not borrowing, but going back to my question, not borrowing, but we are regrouping. We're doing 6 plus 9. 6 plus 9 equals 15. I'm going to carry my 1, put down my 5. 1 plus 7 equals 8. 8 plus 4 equals 12. Put down my 2, carry my 1. 1 plus 5 equals 6. 6 plus 3 equals 6 plus 3 equals 9. So we have 925. Okay. Now, when we go to my non-regrouping problem, that means we're not going to have to regroup, literally. So 2 plus 7 equals 9. 4 plus 2 equals 8. Or 6, I'm sorry. Multiplication here, not addition. Oops. Okay, 3 plus 5 equals 8. So we have 869 and 925. Notice I needed to regroup here, and notice in my problem that I didn't need to regroup, I literally did not need to regroup. Okay. All right, number 9. It says Kelly wants to decorate her room with a mirror and 3 decals. Okay, we have 2 different things going on here. We have a mirror and 3 decals. If the mirror costs $12, which she bought 1 mirror, okay, and the decals are $7 each, okay, which she bought 3 decals, okay, she wants to decorate it with 3 decals, okay. It says, how much will Kelly have to spend? So I'm going to show you exactly how we're going to break this problem down, okay. All right, now first things first, I put down my information. So I have 1 mirror and 3 decals that Kelly wants to decorate her room with. And then I have the information that they gave us about how much it costs for a mirror and decals, okay? So 1 mirror costs $12 and 1 decal costs $7. Now, if it says she wants 1 mirror, that means we know it's just gonna be $12 for that one, okay? So she's gonna pay one set of $12 for a mirror, okay? Now, when it asks how much she will need to pay for 3 decals, all we need to do is how much is 3 decals? We know that 1 decal equals $7, so 7 times 3, okay, equals 21. That will be $21 for the amount of decals that she wants, including the price that it costs for 1. So we know 21 and 12 is what we have. And then it says, how much will Kelly have to spend? Now, when it says how much Kelly will have to spend, we're figuring out how much she will have to spend total. So 21 plus 12, okay? So 1 plus 2 equals 3, and then 2 plus 1 equals 3. So we have $33. Okay. All right, our next question, number 10, it says Ricky wants to buy 3 movies and 5 video games. If each movie costs $20 and each game costs $30, how much will Ricky spend? So this is kind of the same kind of problem that we just did a second ago. It's all we're doing is we're just changing, the information is just changed. So we have movies and video games now instead of mirrors and decals. Okay, so I'm going to show you exactly how we're going to break this down. All right, so basically we're gonna break down this problem again. So if we know one movie equals $20 and one video game equals $30, and Ricky wants to buy 3 movies and 5 video games, all we need to do is break down this problem. So first things first, let's go with the movies, okay? So if we have 3 movies and each movie costs $20, we're gonna do 20 times 3, okay? Cover the 0, and we do 2 times 3. 2 times 3 equals 6, okay? And then carry down the 0, we have 60. So he would spend $60 on movies, okay? Now let's move to video games. If one video game costs $30 and he wants 5 video games to buy, we're going to do 30 times 5, okay? Cover your 0, 3 times 5 equals 15, and then bring down your 0, you're gonna have $150, okay? Now it says, how much will Ricky spend? So we're gonna do 150 plus 60, because we wanna know how much he spent altogether, how much he spent in total. 0 plus 0 equals 0, 5 plus 6 equals 11, carry the 1, 1 plus 2 equals 2, 210. But not just 210, 210 what? $210, okay? All right, number 11 says, Roger has sunflower seeds in 2/4 of his bird feeders and nuts in 1/2 of his bird feeders. All of his bird feeders are the same type. Roger says 2/4 and 1/2 are equivalent fractions. Is he correct? Use the number lines below to help. Choose the best answer. Now, instead of me showing you, we're just gonna pretty much go over this. So make sure you're listening along. So if we're taking a look at our fraction that we're given, 2/4 and 1/2, we know that one number line needs to be in halves and one number line needs to be in fourths. Okay, so when we take a look at this first number line, I know you can't really see what I'm talking about because my clicker is not showing it. Okay, my mouse isn't showing it. If you take a look, that first number line is going in fourths. So we have 0, and then we have 1, 2, 3, 4. We have 4 parts going up to the whole. So that means that one is definitely in fourths. So after 0 would be 1/4. After 1/4 would be 2/4. After 2/4 would be 3/4. And after 3/4, that 1 would represent that 4/4, that whole. Okay. So we can see that. Now, when we look in the second number line, we have 0, and then after 0 would be 1 and 2 parts leading up to the whole. So we know that whole would be 2 halves. In the middle would be the 1/2 after 0. So if you take a look, 2/4 and 1/2 would be in the same position as each other. So that means the answer is B. Yes, 2/4 and 1/2 are the same distance from 0 when the wholes are equal. Okay, so all you have to do is line it up and circle that middle section, and you will see that 2/4 and 1/2 are in the exact same position. Okay, number 12. It says, yes, I'm going to say Yasmin drew a quadrilateral. It has 2 pairs of parallel sides. Which shapes could Yasmin have drawn? Select all that apply. Now, when we're thinking about this problem right here, remember parallel lines are those lines that never intersect, that always keep going. So we're thinking about a square, we're thinking about a rectangle, a parallelogram, and a rhombus. Now, I know you had most of it, but make sure you get all of it, because it did say select all that apply. So don't just select a couple. Make sure you also have square, rectangle, parallelogram, and rhombus. That's 4 quadrilaterals, okay? And that concludes our work for today. Stay tuned, and I will play a video for you, and you will see the next video tomorrow.
Check it out. Yeah. If 7 guys walked down the street and picked up trash, 9 pieces each, how much trash would be up off the street? That's 7 times 9, and that's 63. Cause
if 7 kids wanted to have fun and bought 3 toys for each and every one, how many toys would that be? A ton? Well, 7 times 3 is 21. Cause
7 times 1 is 7. 7 times 2 is 14. Right. 7 times 3 is 21. It's like I'm
crouch down and I'm ready to run. Because
7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. I know all the 7 facts. Do you?
7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. And 7 times 10 is 70. Here we go.
Isn't there a name for the numbers on these tables? Like 14, 21, and all the rest? Those numbers are multiples of 7, you bet. So when you multiply 7, that's what you get.
Here we go. 7 times 6 is 42. 7 times 3 is 21. 7 times 5 is 35. 7 times 9 is 63. 7 times 2 is 14. 7 times 10 is 70. 7 times 1 is 7. 7 times 8 is 56. 7 times 4 is 28. 7 times 7 is